Hello, ladies and gentlemen. Today we're going to talk about combining functions together, different ways that we can combine them together. Specifically today we're going to talk about how to add, subtract, multiply, and divide functions. And then tomorrow we're going to move into what's called composing functions, basically where we stuff them into each other, okay? So what you need to know about combining functions, basically the way that you do it is the way you think you would do it, right? If I have two functions, f of x and g of x, and they have to have overlapping domains, when I go ahead and I want to add them, subtract them, multiply, or divide them, I basically just do just that. So for the sum, I take, if I want to do f of x plus g of x, that's all I'm going to do my sum. Okay, that's the sum of those two functions together, okay? If I want to do a difference, I just subtract them. F of x minus g of x. Okay, for the product, I just multiply them. F of x times g of x. And then for the quotient, I divide them. F of x divided by g of x. Now, you'll sometimes see these written a little bit differently. Sometimes you'll see it as f plus g of x in that way. And again, they're just telling you, hey, add these together, okay? Same things apply for our normal addition, subtraction, multiplication, division. With the sum and the product, your order does not matter. You can multiply them either order and you're good. With the difference and the quotient, the order does matter, okay? F minus g of x is different than g minus f of x, okay? Kind of common sense things we already know about these, but we have to make sure we keep that in track as we do this process, okay? So here's an example. Hey, I have two functions. Here's f of x and here's g of x. I want to find the sum, difference, product, and quotient, okay? Again, these are not really a trick question. You're just going to do what it tells you to do. For the sum, I'm just going to add them together. So I'm going to say, all right, I want to do 2x plus 1 plus x squared plus 2x minus 1. And I just combine like terms, okay? So 2x and 2x is going to be 4x. I'm going to have x squared plus 4x, and then 1 and negative 1 will be 0. That'll be the sum of them together, okay? For the difference, it doesn't really tell me the order for the difference. I'm going to assume they want me to go do f minus g of x, okay? If I wanted to, I could do g minus f of x, but I'm going to do f minus g of x. So that's going to be 2x plus 1 minus, and I have to remember I'm subtracting all of g of x, so I'm going to put that in parentheses so I remember to distribute this negative, okay? But we're going to go ahead and we're going to subtract this. So let's distribute this negative through. I'm going to get 2x plus 1 minus x squared minus 2x plus 1. These two x's will cancel when I go to combine like terms. I'm going to end up with, and 1 plus 1 is 2. So I'm going to get negative x squared plus 2 as being the difference of the two. Okay, just again, all I'm doing there is I am subtracting g of x from f of x. If I want to go ahead and do the product, I'm going to just multiply them. So it's going to be 2x plus 1 times x squared plus 2x minus 1. And all I'm going to do for this is distribute, okay? You can think of it like foiling it out, all right? So we're going to do 2x times each of these, and then we'll do the 1 times each of these. So I'm going to get 2x cubed plus 4x squared minus 2x plus x squared plus 2x minus 1. Combine like terms together, I'll get 2x cubed plus 5x squared. The negative 2x and 2x will cancel and go away, minus 1. And there we go, that would be the product of these two, okay? Quotient might actually be the easiest one, okay? When you go to do quotient, you're just going to divide them. So you have x squared plus 2x minus 1. Oh, actually, hold on, I'm doing this backwards. Let's do this in the correct order. We're going to do f of x divided by g of x. Okay, go in the order that's listed like we did before. So it's going to be 2x plus 1 divided by x squared plus 2x minus 1. And the only thing that you need to worry about with the division, honestly, you write them over top of each other, and then you just say, all right, do either of these factor, does anything cancel out to simplify, okay? If nothing cancels out to simplify, there's your final answer. That's your new function you got by dividing these, okay? If something does cancel out or simplify, you need to cancel out and simplify it, and then state what sort of errors you might have from that, okay? So if something canceled out, you basically need to say, hey, there was a removable discontinuity here based off my division that I had, okay? But this one, nothing factors, nothing's going to cancel out, so this is what we get as our final answer, and that's all we have to worry about, okay? So basically, add them, subtract, multiply, divide. If you know how to do that, it's basically just combining like terms and foiling, multiplying stuff out and simplifying that way, okay? Here we're going to do f divided by g of x for f of x, if f of x is the square root of x, and g of x is 4 minus x squared, and we're going to give the domain of the resulting function. So f divided by g of x is going to end up being the square root of x over the square root of 4 minus x squared. Okay, and again, I would want to look for, is there anything that will simplify here for me, or anything that I can do to simplify this? And really, there's not going to be anything to simplify. I would need to be able to take out a square root of x, and I can't do that. What I can do, though, is I can rationalize my denominator, which is what I'm going to do. So I look at this and say, hey, I don't want to square my denominator. That's bad math there. That's bad notation. So I'm going to multiply by this square root of 4 minus x squared in the denominator and the numerator. Okay? And so I'm going to do that, and what that's going to do is down in the denominator, that's going to make it become just 4 minus x squared, which will get rid of that square root, which I don't want any radicals in my denominator, okay? In the numerator, I'm going to end up with, basically you're going to distribute this x through, we're going to end up with a square root of 4x minus x to the third, okay? And nothing's really going to simplify from this, right? I could take an x out and have 4 minus x squared, but that's not really going to simplify out of the square root at all. In the denominator, I could factor this, right? There's a difference of squares. But again, it's not really going to do anything. This is pretty much as simple as we can get here. Okay, but I will say, it does ask me, hey, give the domain of the resulting function. Basically, hey, I can identify that 2 and negative 2 are going to make me divide by 0. So I'll say that, hey, x is a member of the real numbers. Everything's going to work, except that x cannot be 2 or negative 2. So x can't be plus or minus 2. Okay, and there's my domain for this function I have right here. Okay, so combining functions this way, adding, subtracting, multiplying, dividing, basically the same as you would do in numbers. Just have to think about some of the little simplifying things that can happen after you do that. Okay, thank you all for watching.